Now, as you were looking things over yesterday, was there something in particular you would like to look at?
Yes.
Tell me.
Number 20. Thank you.
Oh, number 20. Okay, now there's several ways of doing question number 20. All right, but essentially, you're trying to show that the distance from G to A is the same as the distance from R to P.
No.
Right?
No.
Prove.
Yeah. Oh wait, no, it gives you the. It says it already says equation of apex is the same distance as what it is.
Yeah, that's what I was trying to say.
Oh.
These two things we know are true, and now we're trying to show that GR is the same as AP. Is that correct?
Mm-hmm.
Right, that's what we're trying to prove. Is everybody good with that? Now, I really think this is a really good question. All right, and if you understand this, then I think we're in pretty good shape. All right. So we know starting out that GA is equal to RP. Does everybody agree with that? Now, that's number one. We could say that's given. Now, if I'm looking at this, the next thing I try to throw in is the segment addition postulate.
Yes.
Right? So I think that we could say for part two that GA plus AR equals GR, and AR plus RP is equal to AP, and that's the segment addition postulate. Is everybody okay with that? All right. Now, why is that important? I think that's important because we're trying to prove that AP is congruent to GR. Does everybody agree with that? All right, this is what we're trying to prove. Now, why is that good? Right, it's good now because in my proof, I have two things that I'm trying to get to. Everybody agreeing with me on this, right? All right. Now, here is something I'm looking at, that GA and RP are equal, right? Everybody agree with that? Right. So, if, what can I do? Okay.
Substitution.
What do I want to do?
You could switch GA with RP.
That's right. Let's switch GA with RP. So right here is GA. I'm going to change that to what? RP. So RP plus AR is equal to what? GR. And that's simply a what? Substitution. So we okay with that? Now I want you to see this. AR right here and RP. And AR and what? That's not that hard. So they are equal. So we can say now, we can replace RP plus AR with what? AP is equal to GR. Again, substitution. And look, until you do that on your own, it can be tricky. All right, just writing down what I'm doing is not helpful. Yes, sir.
Well, this is, can't you figure out that AP and GR are equal? Because after the addition, the segment addition, and AR is being added to both GA and RP. So isn't that segment addition, symmetry addition? I thought that was addition symmetry.
Well, there's another way that you could look at that. If you wanted to do it differently, after you did the first step, step 2 could be AR is equal to AR by the reflexive property. Then you could add them together, and you could say that GA plus AR is equal to AR plus AP, and that's the addition property of equality. You agree with that? That make sense? And now GA plus AR is equal to GR, and AR plus AP is equal to AP by the segment addition postulate. Does everybody see I just proved it, what? A different way. That's why I'm saying when I grade your test, it's kind of tricky for me to grade sometimes because I have to figure out how you're thinking about it. All right? So there are alternatives. Just because my way doesn't mean it's the only way. You can see things differently. So bear with me on that. Yes. Let's look at 19. What, go ahead.
AR plus AP.
Oh, I'm sorry. AR plus RP. Right? I meant to put RP there, buddy. Thank you, thank you. Good job. Right? Thank you. All right, now he wants me to take a quick look at 20. Or I'm sorry, 19.
Oh, yes, yes.
So here we go. On this, it says points A, B, and C are non-collinear, which means they form a plane. Do you agree?
Mm-hmm.
And then B, C, D are also non-collinear, so they form a what? They form a plane. Do you agree with that? Now, what I'm trying to get you to understand is that BC and BC are common in both planes. So that intersection, BC is the intersection of both planes. That's all that means. All right, so if you want to try to draw that, right, I'm trying to draw something so you can see what I'm referring to. So this point right here is point B and C. Then I'm going to try to draw another plane. Oh. And then A, B, so I could put A right there, and then I would have to put D over here. And this would be B, and this point right here would be C. You see what I'm saying, right? Does that make sense? So there are two planes that intersect. Kind of hard to draw, but I don't care about the drawing as much as I care you try you drawing it. What?
How are B and C non-collinear if the two planes always intersect on a line?
I don't think that's what it's saying. I think it's saying A, B, and C are not on the same line, right?
So all
But any two of them will be on the same line.
of them. Okay.
Do you understand? And again, I appreciate some of you guys trying to see things because I think that's the hardest part of geometry is seeing things. Does everybody understand my drawing?
Yes.
Okay.
In the instructions, it says describe, so by describe, you mean like draw it?
That would be my description.
Okay.
Alright? Does that make sense?
So if all ABCs were on line, would they still be on plane?
No. You with me? In order to define a plane, you must have 3 non-linear. You with me? Because there's an infinite number of points technically. Remember we said there's at least 2 points on the line. And at least 3 points on the line. Right?
Are there going to be parts of the test like
I'm not worried about that, really. You're doing outstanding. I told you, you just got to go through and make sure you're good. Alright, I know it's kind of tricky starting out, so I'm not going to make it. You know, just do what we've been doing. Alright, I'm not expecting you to see everything. It's tricky to start out. Alright? But I think that proof right there we've done several times, things like it. Agreed? I think you can do that. Alright. I'm just scrolling down, so anybody? Which one? Let's take a look at 21. Now sometimes I don't like these because you know, sometimes you may not see it exactly the way they do. Well, let's see if we can figure this out. If angle 1 and 2 form a linear pair, and 2 or 3 are supplementary, prove 1 is congruent to 3. Well, first of all, if 1 and 2 form a linear pair, and so that's given, right? If they form a linear pair, then they're automatically what? Supplementary. Do you agree with that? And that's by the supplement theorem. Right? Now, why is angle 1 have to be congruent to angle 3? What do you think?
Is it C?
Yeah. Right? And here's what I want to show you. And sometimes that's not easy for kids to see, but if you have 2 angles supplementary to the same angle, then those 2 angles have to be equal. And let me show you why. All right? Angle 1 and 2 form a linear pair, and 2 is supplementary to 3. So if 2 is supplementary to 3, let's just say this is 100 degrees, then this would be what? 80 degrees. Is that true?
Yeah.
So 1 and 2 form a linear pair. So if 1 and 2 form a linear pair, then angle 1 would have to be what? 80. Now can you see angle 1 is congruent to angle 3?
Yeah.
Right? So angles supplementary to the same angle, those angles have to be congruent. Good on this? All right. That was a good question. All right.
35.
Let's scroll down to 35. Oh, yeah, I'm glad you asked me about this. Find the value of x in all the angles. All right, so what type of angles are those?
Vertical.
Vertical, so what's true about those? They're equal. All right, so you have to say x squared is equal to 5x plus 50. Now, if you recall, that is a quadratic. And to solve a quadratic, you have to set it equal to 0. Then you have to factor it. So let's talk. So this now would be x squared minus 5x minus 50 equals 0. Agree with me? And so now we're going to factor that. X, 10, 5, negative, positive. You agree with this? And so x has to equal what? Or negative 5. All right?
Shouldn't it be 10? Oh.
You agree with that? So now we have options here, actually, guys. So if x is 10, the angles could be, that would be 100, right? This would be 100. And the other one would be 80 and 80, right? Or it looks as though this is an extraneous solution. So some people made a mistake of just crossing that out, but that's not true, right? The reason it's not true is because I want to plug it in. So this angle then would be 25. So that would be 25. So this would be 155. And that's 155. Does everybody agree with that? All right. Yes.
I think it looks more realistic that it would be the x equals 10 because.
Yeah, but I'm just saying, what are the possibilities?
Yeah.
Right? You can't just say that because the picture is obtuse, it's not the right one. Everybody hear me on that? It's just the possibilities. All right, if two lines intersect and their intersection is x squared and 5x plus 50, those are the options. All right, that was a good question. What? Okay. Yeah, this is a really nice problem, guys. Really, really nice. Can someone tell me why that's not true? Most people think it is true. It sounds true. You're 100% correct. It does. But that means you're not seeing all possibilities. What's the matter?
Well, it could be midpoint, but they also could be congruent in any shape, or just like, or parallel.
You are 100% correct. So it could be this. Look. Here is M. Here is N. Here is NP. That's equal to that. Do I agree with that? That's a common question on a lot of SAT tests. Everybody see that?
I just don't understand what a counterexample is.
Counterexamples just show me a reason why it's false.
Oh.
Right? I just showed you why it could be false. Could it be true?
Yes.
Yeah.
Could be true. But if it's false for just one example, then the whole statement itself is what? False. Are we okay with that? Walker, what you need?
You go back to 27.
Let's look at 27 real quick. What's the matter?
I didn't understand.
Well, 4 and 5 have to add up to 90 degrees, right?
Yeah.
So this is,
When I did it, I didn't.
so 6x minus 18 has to equal 90, right? So I would divide by 6. X minus 3 equals 15. So x is equal to what? You agree with this?
Yes.
And then you just plug in to figure everything out. All right? Naomi, what?
55.
Let's take a look at 55 real quick. Okay, measure A is that, B is that, A and C are complementary. And B and C are supplementary. So, A and C are supplementary, and B and C are supplementary. So what do you think that means about A and B? That's good, right? Does everybody see how that's true, right? They have to be equal. Right? And again, I know that doesn't always sometimes sound exactly correct. That's why I always try to tell kids, draw, if I just make an example, if that's 80 and that's 100, everybody with me? And I draw another 100 degrees or 80 degrees. These two are what? Supplementary. These two are what? Supplementary. Therefore, these two have to be what? They have to be equal. Listen to what I just said now. Make sure that's making sense. Because for some reason, that doesn't sink in the first couple times you say it. But if you draw it out, you can see how that's clearly true. So again, if you're looking up here, A and C are supplementary, B and C are supplementary. Therefore, A and B have to be equal. Everybody good with this? Oh yeah. So we can just solve that out now, right? Do you agree with me? All right. I don't think the solving was the issue. All right, sorry.
28.
So let's look at 28. What's true about 6 and 7? So that means they're equal. 7x minus 24 equals 5x plus 14. Good? Right? Somebody else? Good.
23.
23, thank you. Oh yeah, this would be a good one to look at. Very nice problem. Okay, so AB is congruent to DE, so I'm going to mark it. AB is congruent to DE, right? B is the midpoint of AC. If B is the midpoint of AC, then what's true about AB and BC? They're equal, right? And if E is the midpoint of DF, then what's true about EF and DE? So what's true about all of them? They're all equal. Do you agree with that? Now that's just obvious based on the fact that I just wrote that in there, correct? But now what the problem is we got to list everything out. All right? So to list it out, again, AB is congruent to DE, B is midpoint, and E is midpoint. Okay, so why is AB equal to DE? Definition of congruent. So some of you now got 2 parts right. Pat yourself on the back. All right, it feels good. So what is true using the definition of midpoint? AB is equal to BC, and DE is equal to what? DE is equal to EF. Does everybody agree with that? All right. Now, why is BC congruent to DE? All right. I'm not sure if I like that. Well, I'm trying to find AB, these two ABs, right, are equal, right? So that's how you see. That is right, substitution. If you put transitive property, I'm not going to argue. Why is BC equal to EF? Substitution. Therefore, BC is congruent to EF by definition of. Come on, guys. Hopefully you get a little better at that now. Say, tell me again. I'm sorry.
Why can't you just skip the B? Why do you do that step?
What would you want me to have? You would want me to go straight to BC equals EF? Yeah. Yeah, but I think why they want you to do that is because you're really substituting in twice. Do you agree? You with me? I know what you're saying. Right? But that would be kind of like a step-by-step thing. Right? And that's why sometimes I like the fill-ins, because everybody's got to do the same way. Right? All right, guys. Somebody tell me something else. Yes. Good for you. Let's look at 50. Very, very, very good problem. Obviously, that is false, right? Because A could be what?
-6.
A could be -6.
Oh.
Right, the square problem I want you to remember because that's always on these types of tests. Can we get on this? Yes, sir.
Number 25.
Okay, let's go back to 25 now. Uh-oh. If A equals 2, so I'm replacing A with 2, right? Then B has to be less than or equal to what?
It says
So the counterexample would be what?
Oh.
Do you guys see that? We're saying that B is less than or equal to 6. It could be really any counterexample could be anything greater than 5, right? All right, guys. I'm feeling pretty good. All right. Sounds like that's good. All right. Please review things. All right. It's not a lot of math, more. Just reviewing definitions, those types of things. Yes, sir.
The answers are on the bottom.
Yeah, now there's a couple of them that I changed, okay, like question 35. I don't know if I fixed that or not. I made that harder. Yeah. So the one I left off, no, X could also be, what was it? -5, right? So then the angles were 25, 25, 1. Okay?
Yes.
Yeah, I think they're down there. I think it's good. All right, guys. Please use your time wisely. Tomorrow, try to get to class as quick as you can. All right, so you can start as quick as you can. Tomorrow is a what? C day, which means we're taking it 6th period, right? Which is, what's that relationship to lunch?
It's right after lunch.
Right after lunch? Is that what it is? Right after lunch? Is everybody hearing me?
Yeah.
Listen, I haven't talked to Mr. Smith, but you guys, if you want to come study, right, I'm in here. If you want to be quiet, somewhere to sit and look over a few things, that's fine. You can come to my room. All right. All right, get to work.